Hello students, welcome to my class. I am Megha Chaturvedi and this is the subject of electronics and devices. And in this class, I will provide the notes and lectures of the topic BJT and MOSFET power amplifier. Now, BJT, which is the bipolar junction transistor, which has the three-terminal circuit or device that amplifies flow of current. It is the solid state device that flow current in two terminals, that is collector, emitter, and controlled by the third device known as the terminal or base terminal. Unlike a normal PN junction, this is transistor which has two PN junction. The basic symbol of BJT are N type and P type. Electronic current is conducted by both free electrons and holes in BJT. The terminals of BJT are the three terminals, which is the first terminal is emitter. It supplies the charge carrier and it is highly doped so that it can inject a large number of charge carrier into the base. Emitter is always greater than base. Base, which is middle layer in BJT, which is thin compared to emitter and collector. Base is very lightly doped. And the third one is collector. It collects the charge carriers. It's doped between the emitter and base, means moderately doped, but it is always greater than emitter and base in size. Now the types of BJT, first one is NPN junction transistor and second one is PNP junction transistor, and we can understand with the help of diagram, which is NPN transistor in the first diagram and PNP transistor in the second diagram, in which single p-type semiconductor layer is sandwiched between the two n-type semiconductor, which is NPN transistor. And when a single n-type semiconductor layer is sandwiched between two p-type semiconductor layer, it is PNP transistor. Now the operations of BJT, it consists three modes. First one is cutoff mode, second one is saturated mode, and third one is active mode. In BJT we need supply DC voltage to NPN and or PNP transistor in order to operate transistor in one of these regions. Transistor operates in any of these regions based on polarity of DC voltages. Applying DC volt means biasing of transistor. Now the first operation mode is cutoff mode. In this mode, both junction are reverse biased, so no current flows through the device. Hence, the transistor is in off mode and act as like a open switch. This mode is used for switch off application. Now the second one is saturated mode. In this mode, both the junction are forward biased, so the current flows through the device. Hence, the transistor is in on mode and act like closed switch. This mode is used for switch on application. And this is the diagram of both the modes, that is cutoff mode and saturation mode. Now in active mode, one junction is forward bias and another junction is reverse bias. This mode is used for amplification of current. And this is the diagram of active mode device. Now the advantages of BJT. These are the advantages of BJT, in which the first one is it has high frequency operation, and second is it has high driving capability, and third one is it is used as digital switch. Now the application of BJT. Bipolar junction are mainly used in switching and amplification, and it includes the radio transmitter, audio amplifier, TV, computer and mobile phones, etc. Now our next topic is MOSFET and its type and working principle. MOSFET, which is a metal oxide semiconductor field effect transistor, which has the four terminal, that is source, gate, drain and body. It is a semiconductor device which is used for switching and amplification application in electronic circuit. In general, the body is connected with the source, thus forming the three-terminal device like an FET, which is field effect transistor. The MOSFET is a voltage control device since its operation depends upon the flow of majority carrier only. Hence, MOSFET is a unipolar device. In other words, an FET that can be operated in enhancement mode. is known as MOSFET. Why the name MOSFET comes? Its answer will be the gate terminal is insulated from channel with the help of metal oxide, which is silicon oxide, and hence the name MOSFET. This is the type of MOSFET. The first one is depletion type, which can be symbolized as D MOSFET. The second one is enhancement type, which can be symbolized as E MOSFET, and further it can be divided in two parts, that is N channel D MOSFET and P channel D MOSFET, and the enhancement type further divided into N channel E MOSFET and P channel E MOSFET. The first one is depletion type MOSFET, in which the types are N channel D MOSFET and P channel D MOSFET. Now the N-channel D MOSFET can be defined as the P-type substrate make narrower channel between the source and drain, so that only passes remain for the flow of electron when the drain is made positive with respect to the source. This is the symbol of N-channel D MOSFET. Now the P-channel D MOSFET, which is the N-type substrate, constrict the channel between the source and drain so that only a small passes remain for the flow of holes from source to drain. Now the second one is depletion mode operation. Since the gate is at negative potential, hence there are electrons on the gate, these electrons repel the free electron in the N channel so that the N channel is depleted of some of its free electron. Thus lesser number of free electron are available for the current conduction through the channel. This effect is same as the resistance of channel is increased. The higher the negative voltage at the gate terminal causes the small is the current from the source to drain. Hence, by changing the negative voltage on the gate, resistance of the N channel can be varied. Hence, source to drain current. Since the operation with negative gate depends upon depletion or emptying the channel of free electron, hence the negative gate operation is known as depletion mode operation. Now the enhancement mode operation. Since the gate is positive, it induces negative charge in the channel by capacitor action. These free electrons are added to those already in the channel. Thus the total number of free electrons in the N channel is increased. Hence a positive gate voltage increases or enhances the conductivity of the channel. The higher the positive voltage on the gate, greater the current from the source to drain. Thus by changing the positive voltage on the gate terminal, the conductivity of channel can be altered. Since the operation with positive gate depends upon the enhancing the conductivity of channel, the positive gate operation is known as enhancement mode operation. Now the application of MOSFET comes. First one is MOSFET amplifier are widely used in radio frequency application. The second is speed of DC motors can be regulated with the help of power MOSFET. And third, due to high switching speed, it can be used in chopper circuit. Now the advantages of provides MOSFET provides higher efficiency while operating at lower voltages. The second is due to high input impedance, MOSFET has high switching speed. It can quickly changes the speed. Now the next topic is power amplifier. After the audio signal is converted into electrical signal, it has several voltage amplification done, after which the power amplification of the amplified signal is done just before the loudspeaker stage. This is clearly shown in the below figure, which has the microphone. The output of the microphone comes to the voltage amplifier, then to the voltage, again to the voltage amplifier, then comes to the power amplifier. Power amplifier gives the output to the finally loudspeaker. While the voltage amplifier raises the voltage level of the signal, the power amplifier raises the level of the signal, so we can get the high amount of strength and audio from the loudspeaker. Besides raising the power level, it can also be said that a power amplifier is a device which converts DC power to AC power, whose action is controlled by the input signal. DC power output, which is equals to the AC power output plus losses, that is the summation of AC power output plus losses. Now the power transistor, it is a normal transistor. For such power amplification, normal transistor would not do. A transistor that is manufactured to suit the purpose of power amplification is called the power transmit transistor, and it differs from the other transistor in the following factors. It is larger in size in order to handle large power. The collector region of the transistor is made large, and heat sink is placed at the collector base junction in order to minimize the heat generated. The emitter and base region of a power transistor are highly doped due to the low input resistance. It require low input power. Hence, there is a lot of difference in voltage amplification and power amplification. Now, the voltage amplification or amplifier, which is to raise the voltage level of the signal. It is designed to achieve maximum voltage amplification, which is mathematically given by AV is equals to B into RC upon Rn. The characteristics of voltage amplifier are as: the first one is the base of the transistor should be thin, and hence value of beta should be greater than 100. The resistance of input resistor should be low when compared to collector load RC. Collector load RC should be relatively high. To permit high collector load, the voltage amplifier are always operated at low collector current. The voltage amplifier are used for small signal voltages. Now this is the tabular form of difference between the parameters of voltage amplifier and the power amplifier. The first one is beta, which is high in voltage amplifier and low in power amplifier. Collector resistance, which is high in voltage amplifier and low in power amplifier. The third one is coupling, usually RC coupling used in voltage amplifier, and power, uh, invariably transformer coupling in the power amplifier. Now the V in, which is low in voltage amplifier and high in power amplifier. The collector current, which is low in voltage amplifier and high in voltage amplifier. Power output, low in voltage amplifier and high in power amplifier. And the last one is output impedance, which is high in voltage amplifier and low in power amplifier. This is all about this lecture. Thank you very much.